Hello students, I am going to deliver a lecture on half-range Fourier sine series in second unit of transforms and partial differential equations. So first we will see the definition of half-range Fourier sine series. The half-range Fourier sine series for the function f of x in the interval 0 less than x less than L is given by f of x equal to summation n equal to 1 to infinity bn sine n pi x by L. Here the value of bn is found by using the another formula bn equal to 2 by L integral 0 to L f of x sine n pi x by L dx. In this formula, if we replace L by pi, then we will get one more formula, that is the half-range Fourier sine series in the interval 0, pi, and is given by f of x equal to summation n equal to 1 to infinity bn sine nx, and the value of bn is 2 by pi integral 0 to pi f of x sine nx dx. For now, we will see some problems based on half-range Fourier sine series. So first problem is obtain the half-range sine series of the function f of x equal to kx into x minus L in 0 less than x less than L. Here the function is defined in the interval 0 to L. So we know the formula for half-range Fourier sine series in the interval 0 to L. So first you have to write that formula f of x equal to summation n equal to 1 to infinity bn sine n pi x by L, where bn equal to 2 by L integral 0 to L f of x sine n pi x by L dx. For next we have to find out the value of bn here. So we know the formula for bn. Then now you have to replace the value of f of x here. In this problem, the value of f of x is given by kx into x minus L. So that here I am replacing f of x by kx into x minus L sine n pi x by L dx. Here the value of k is a constant, so it can be taken out. So 2k by L integral 0 to L x square minus Lx sine n pi x by L dx. Now you want to integrate this function with respect to x. Here it is a product of two functions. So you have to apply Bernoulli's formula, integral u dv equal to uv minus u dash v1 plus u double dash v2 minus etc. Here the value of u is equal to x square minus Lx, and dv is the remaining factor sine n pi x by L dx. So in this formula, we need the value of u dash, u double dash, and v1, v2, etc. So first you have to find out the value of v. So v is obtained by integrating the value of dv. So integrating on both sides, we will get the value of v. V is equal to integration of sine. Integration of sine is minus cos. So minus cos n pi x by L divided by the constant term n pi by L. For next you have to find out the value of successive derivatives u dash, u double dash, u dash. So u is x square minus Lx, for u dash is equal to 2x minus L. Here I am differentiating with respect to x. The differentiation of x squared is 2x. Okay. Then u double dash. So u double dash is the differentiation of u dash. U dash is 2x minus L. So we have to differentiate with respect to x. The differentiation of 2x is 2 and L is a constant term, so that its derivative will be 0. Find out the corresponding v1 and v2. So v1 is the integration of v. Already we found that the value of v is equal to minus cos n pi x by L divided by n pi by L. Now you have to integrate this function with respect to x. You will get the value of v1. So integration of cos sine. So minus sine n pi x by L divided by n square pi square by L square. Again we have to integrate with respect to x. We get the value of v2. So we know the formula for integration of sine. Integration of sine is minus cos. Already we have one minus symbol. So plus cos n pi x by L divided by n pi by L. Already we have n square pi square by L square. Now it is n cube pi cube by L cube. Now replace all the values in a formula, integral u dv formula. We will get this expression like this: 2k by L x square minus Lx into minus cos of n pi x by L divided by n pi by L minus 2x minus L into minus sine n pi x by L divided by n square pi square by L square plus 2 into cos of n pi x by L divided by n cube pi cube by L cube over the limit 0 to L. For now you want to replace the limit x by L, that is the upper limit. So you have to replace the value of x by L here. Minus is here I am writing the symbol minus at the front. So minus of L square minus L square cos n pi. You have to replace the value x by L. When you are replacing x by L, L cancelled. So cos n pi by L. Then, so here we have two minus symbols, so it becomes plus. So plus 2L minus L sine n pi. When you replace x by L, L will be cancelled. So sine n pi by n square pi square by L square. Plus 2 cos n pi by n cube by L cube. This is the upper limit part. Minus of, you have to put the lower limit x equal to 0. When you put x equal to 0 in the first part, it becomes 0. X square is 0 minus L into 0. The first part becomes 0. Minus of 2 into 0 minus L into sine 0. Sine 0, you know the value of sine 0. Sine 0 is 0. The second part becomes 0. Plus 2 into cos 0. Cos 0 is 1. So 2 divided by n cube pi cube by L cube. So which is equal to 2k by L. The first two terms become 0. Because L square minus L square is 0 and sine n pi is 0. So first two part becomes 0. We will get only the last two terms. So 2 cos n pi by n cube pi cube by L cube minus 2 by n cube pi cube by L cube. Here 2 by n cube pi cube by L cube is a constant term, so it can be taken out. For now, in the denominator, one L term will be cancelled. After that, it will go to the numerator. So 4k L square by n cube pi cube into cos n pi minus 1. Cos n pi, we know the value of cos n pi is minus 1 power n, so minus 1 power n minus 1. So this is the value of Bn here. Now, it will be discussed under two cases. When n is even, so what about the value of Bn here? So when n is even, put n equal to some even numbers. For example, n equal to 2, 4, 6, etc. So in the part of minus 1 power n minus 1, so it will be 0. So the value of Bn equal to 0 when n is an even number. So when n is an odd number like 1, 3, 5 something. When you put n equal to, for example, when you put n equal to 1, you will get minus 2. Okay, so when n is an odd number, the bracket term becomes minus 2. So and now in the front, we have that factor 4k L square by n cube pi cube. So these two factors can be multiplied. So we'll get minus 8k L square by n cube pi cube. This is the value of Bn. Now substituting the value of Bn in a Fourier series, we will get the recursive Fourier series f of x equal to summation n equal to 1, 3 to infinity, because the value of n is odd here. So minus 8k L square by n cube pi cube sine n pi x by L. Here minus 8k L square by pi cube, which is free from n, so that this factor can be taken out from the summation part. For summation n equal to 1, 3, 5 to infinity 1 by n cube sine n pi x by L. So this is the answer for the given problem. And now further we can simplify this one, because here n equal to 1, 3, 5 to infinity 1 by n cube. This can be replaced by summation n equal to 1 to infinity 1 by 2n minus 1 the whole cube. So we can replace, when you put n equal to 1 to infinity, we can replace the term n by 2n minus 1. So this is the Fourier series of the given function. So this is the answer for your first problem. Now for the second problem, find the half-range Fourier sine series for the function f of x equal to x cos x in the interval 0, pi. So in the interval 0, pi, we know the Fourier sine series formula. F of x equal to summation n equal to 1 to infinity bn sine nx. And the value of bn is 2 by pi integral 0 to pi f of x sine nx dx. For now, here we have to replace the value of f of x here. F of x is x cos x into sine nx dx. Now the integrand part is a product of three terms, x sine nx cos x dx. And now you know the formula for 2 sin A cos B. 2 sin A cos B is equal to sin A plus B plus sin A minus B. By using this formula, we can write sin nx cos x dx as sin n plus 1 into x plus sin of n minus 1 into x divided by 2 into dx. Now the term 2 cancelled, so you get 1 by pi into integral 0 to pi x into sin of n plus 1 into x plus sin of n minus 1 into x dx. Now the integration of first term, integral x sin n plus 1 into x dx, plus apply the integration to the second term, integral 0 to pi x into sin of n minus 1 into x dx. Now again here we are using a product rule, that is the integral u dv formula. Here u is equal to x and dv equal to sin of n plus 1 into x dx. So we can write u is x, v is integration of sine. Integration of sine is minus cos. So minus cos of n plus 1 into x divided by n plus 1. The formula is uv minus u dash. U dash is 1 because u is x, so u dash is 1, and v1. V is minus cos. So v1 is, we have to integrate with respect to x. So integration of cos is sine. So already found minus symbol. So minus sine n plus 1 into x divided by n plus 1 the whole square. Plus, and for the second part of integration, u equal to x and dv equal to sine of n minus 1 into x dx. So x, u, v is integration of sine minus cos. So minus cos of n minus 1 into x divided by n minus 1 minus u dash. U is x means u dash is equal to 1. So 1 into v is minus cos. So v1 equal to minus sine of n minus 1 into x divided by n minus 1 the whole square. So over the limit 0 to pi. Now you have to replace the term x equal to pi, that is the upper part, minus pi cos of n plus 1 into pi divided by n plus 1 plus sine of n plus 1 into pi divided by n plus 1 the whole square minus cos of n minus 1 into pi divided by n minus 1 plus sine of n minus 1 into pi divided by n minus 1 the whole square minus of, similarly you have to replace the term x by 0, that is the lower limit. So when you replace x equal to 0, the first part becomes 0 because x into minus cos of n plus 1 is there. So 0, the first part becomes 0. And for the second one, when you put x equal to 0, you will get sine 0. Sine 0 is 0. Okay, for the first two terms become 0. And for the third one, when you replace x by 0, the third part is also 0. And for the fourth one, when x is equal to 0, we'll get sine 0. Sine 0, we know the formula for sine 0. Sine 0 is also 0. So 4 terms become 0. So lower part is 0. And for the first one, minus cos of n plus 1 into pi divided by n plus 1. For sine of n plus 1 into pi. For the second one, sine of n plus 1 into pi. We know the value of sine of n pi. Sine of n pi is 0. Sine of any pi value is 0. So sine of n plus 1 into pi is becomes 0. And for the third one is as it is, minus pi cos of n minus 1 into pi divided by n minus 1. And for last term, see the last terms. Last term is sine of n minus 1 into pi. The sine of any pi value is 0, so last term becomes 0. Okay, so 1 by pi. For cos of n plus 1 into pi. So cos of n plus 1 into pi, but that can be expanded in the form of cos of a plus b form. Cos of a plus b is equal to cos of a cos b minus sin a sin b. So by use of that formula, here I am expanding here. Similarly for the second one, cos of a minus b. Cos of a minus b is cos a cos b plus sin a sin b. So by using that formula, here I am expanding the second factor also. For now, and for the first one, we have a factor sin n pi sin pi. Sin n pi value is 0, so second factor equal to 0. And for the fourth one is also 0 because we have the factor sin n pi sin pi. For these two terms are 0. So we get cos n pi cos pi divided by n plus 1 plus cos n pi cos pi divided by n minus 1. So cos n pi cos pi is common. And we know the value of cos pi. Cos pi is minus 1. Already have one minus symbol, so plus cos n pi 1 by n plus 1 plus 1 by n minus 1. So cos n pi value is minus 1 power n. So replace that value here. And taking LCM, for n plus 1 into n minus 1 is a common factor. So when you multiplying these two factors, we will get n square minus 1 in the denominator. So numerator becomes 2n. So 2n into minus 1 power n by n square minus 1 is the value of bn, provided the value of n is not equal to 1. Suppose if you are replacing this value in your Fourier series formula, you will get the value of f of x equal to infinity at n equal to 1. So in order to avoid this one, you have to find out the value of b1 separately. So when n equal to 1, b1 equal to. So replace the value of n equal to 1 in your bn formula here. So b1 equal to 2 by pi integral 0 to pi x cos x sin x dx. Okay, for now we know the formula for 2 sin a cos b. 2 sin a cos b is equal to sin 2x. 2 sin 2a. So sin 2x. 2 cos x sin x is replaced by sin 2x. Now again by using a integral udv formula, so u is equal to x and dv equal to sin 2x dx. So u x, dv is sin 2x, so v is equal to minus cos 2x by 2 minus u dash is 1, v1 is minus sin 2x by 4. Then replace the values upper limit and lower limit. After simplification, we will get minus 1 by 2. Now substituting these two values, that is the bn and b1 in your Fourier series formula. F of x equal to summation n equal to 1 to infinity bn sin nx is our formula. But here I am writing bn sin nx as b1 sin x plus summation n equal to 2 to infinity bn sin x. So b1 value is minus 1 by 2 sin x, and then replace the value of bn 2n into minus 1 power n by n squared minus 1 sin nx. So this is the answer for your Fourier series. Thank you.